Ready to dive into something pretty amazing? Microchip manufacturing.
Yeah, it's one of those things, we use them every day,
Right.
but probably don't think about how they're made.
Exactly. Like I'm holding my phone right now.
Uh-huh.
It's got a ton of microchips in it.
Absolutely.
And it's just wild to think about how we get from like basic elements, silicon,
Right.
to these incredible, tiny, powerful devices.
Yeah, it's a wild journey, it really is.
So we've got expert guides and diagrams to help us along the way.
We do.
Get ready for a trip from the beach to the silicon heart of modern technology.
I love that. From the beach, so it starts with sand, right?
Yeah, it all starts with sand, which is kind of mind-blowing in itself.
It is. I mean, the most abundant element on Earth, oxygen, isn't the key ingredient here.
Right.
It's the second most abundant silicon, and it's found in plain old sand.
It's incredible.
Yeah, so we take the sand, and through some, pretty incredible processes, we transform it into these massive silicon ingots.
Ingots, okay, so I'm picturing like
Big,
this
giant.
giant block of something.
Yeah, they're these ultra pure crystals, and they're the foundation of every single microchip.
But if I'm thinking of like a sculptor,
Yeah.
right? They start with a giant block of marble.
Exactly.
This is kind of the silicon equivalent of that.
It really is, and just like a sculptor, microchip manufacturers have to be incredibly precise.
Precise, yeah.
These ingots are sliced into these super thin wafers, like thinner than a human hair.
Wow.
And then they're polished to this, you can't even believe how smooth they are.
So why is that level of precision so important?
Well, think about it this way. If you were building a skyscraper and the foundation wasn't perfectly level,
Uh-oh.
it just wouldn't work right.
No.
Same with microchips. Any imperfection, anything, can lead to flaws in the circuitry later on.
So we've got our perfectly smooth wafer.
We do.
What happens next? How do we actually get the circuitry onto this blank slate?
That is the magic of photolithography.
Okay, photolithography.
It's complex, but it's also surprisingly familiar. Imagine you're projecting a city blueprint
Okay.
onto that wafer
Right.
using light and a stencil.
Got it.
That's basically photolithography. It's creating the pattern for all those intricate circuits.
So like we're laying out the map of where all the transistors and connections need to go.
Exactly, yeah. And that blueprint is what we call a photomask.
Photomask.
It's like a stencil,
Yeah.
and the wafer is coated with this light-sensitive material called photoresist.
Yeah.
Then ultraviolet light shines through that photomask, hardens the exposed parts of the photoresist.
It's like developing a photo almost.
It really is, but on a microscopic scale and with, well, pretty high stakes.
I bet. And wouldn't that be slow for like mass production?
Yeah, speed is definitely key.
Yeah.
So over time, they've developed some super sophisticated techniques to streamline the process.
Like what?
Lasers, advanced optics,
Wow.
all to project these super detailed patterns onto the wafer, and fast.
That's amazing.
So now we've got the blueprint, it's etched on there, but we're still just dealing with a flat surface.
Right. How do we get that 3D complexity that a microchip has?
It's where things get really interesting. We need depth, and that's where etching and ion implantation come in.
Okay. Etching and ion implantation. Those sound pretty high tech.
They are. Etching is basically a super controlled erosion process. We use chemicals or plasma to carve out tiny trenches and structures into the silicon,
Oh, wow.
making space for those transistors and the wiring.
So that gives us the hills and valleys of the chip.
You got it. But it's not just a physical structure.
Right.
We need to change the electrical properties of the silicon itself.
And that's where the ion implantation comes in.
You got it. It's kind of like using microscopic cannons to shoot ions.
Ions.
They're atoms with an electrical charge.
Okay.
And we fire them at very specific areas on the wafer. This changes the silicon's conductivity.
So we're literally changing the silicon itself.
We are, so that it can act like a switch.
Right, because you need those on-off switches for computing.
Exactly. It's all about the transistors being able to switch on and off.
So now we've got the etched wafer. Those regions are tiny switches.
We do.
Getting closer.
Yeah.
But how do we get to all those layers? I mean, it's more than just the surface, right?
Absolutely. We got to build up, create layers of complexity to get that microchip functionality.
Yeah, how do we do that?
Imagine a network of microscopic highways and bridges all connecting the transistors.
Okay, so like a microscopic city.
Yeah, with layers of interconnected structure.
Wow, and how do we actually build that?
With a process called deposition, we lay down thin layers of materials, copper, aluminum. They form the interconnects, the wires that connect everything.
Like the electrical grid of our tiny city.
Exactly, making sure all the components can talk to each other.
That's incredible.
And here's the mind-blowing part. This whole sequence, photolithography, etching, ion implantation, layering,
Yeah.
it's repeated dozens of times
Oh, wait.
to make the 3D structure of a modern microchip.
That's like building a skyscraper.
I know.
Floor by floor.
One meticulously crafted floor at a time.
Wow. And with each layer, we're getting more complexity, more functionality.
Exactly, yeah. Each layer builds upon the previous one,
Right.
creating this incredibly dense network of transistors, interconnects, all working together
Yeah.
to do those complex calculations that make our devices so powerful.
But even with all that precision, there's got to be room for error, right?
Yeah, absolutely.
Like one speck of dust.
One speck of dust, a temperature change
Right.
could ruin the whole thing.
So quality control must be like the biggest thing.
It is paramount. Every single chip goes through rigorous testing. They use special equipment
Wow.
to check for defects, any deviation.
It's like a final exam for every chip.
It really is. Only the chips that pass, they move on.
So we've got our wafer
Huh.
full of perfectly formed, tested microchips.
Yeah,
But they're still part of the wafer, right?
they are. So then it goes through a process called dicing.
Dicing.
They
Okay.
cut the wafer up into individual chips, like a baker cutting brownies out of a pan.
Makes sense. It's amazing that something so tiny can be so powerful.
It is. But they're still delicate. They need protection
Right.
before they can be shipped off.
So what's the final step?
Packaging. Each chip is mounted on a substrate, kind of like a circuit board, and then encased in a package made of plastic or ceramic,
Okay.
protects it, and provides the connections so it can talk to other parts of a device.
So we take this amazing brain, give it a skull and a nervous system.
Exactly. That's a great way to put it.
And that's how we get from silicon in sand to the brains of our devices.
We do. It's a pretty incredible journey.
Pretty mind-boggling.
It is. But we can't stop there.
Right. We got to talk about the future.
Absolutely. This is just the beginning. The world of microchips is constantly evolving.
So what does that mean for technology? What's next?
Well, that's a conversation for part 2.
Stay tuned. We'll be back soon to explore the cutting-edge advancements that are going to revolutionize the world of microchips.
Welcome back to our deep dive into microchips.
You know, in part 1, we went from silicon to circuitry.
Unraveling all those steps, making those technological marvels.
It was wild to see how something so small can be so powerful.
Right.
But like you said, there's more to the story.
Oh, absolutely. The world of microchips, it's always changing.
Yeah.
Always that push for more power, more speed, more everything.
So in this part, let's explore those advancements.
Yeah.
The ones that are really pushing the boundary.
From the tiny to the mind-bending.
Okay, let's start with something that's been getting a lot of buzz. Quantum computing.
Yeah, quantum computing.
It sounds like sci-fi, honestly.
It does, but it's real.
Right.
And it has the potential to change, well, everything.
Mm.
Medicine, materials science, you name it.
So what is it exactly? How is it different from the computers we use every day?
Well, traditional computers use bits, right? Zeros and ones.
Right, like a light switch, on or off.
Exactly. But quantum computers, they use qubits. They can be a 0, a 1, or both at the same time.
Wait, how is that even possible?
That's quantum mechanics for you, the science of the very, very small.
So like atoms and stuff?
Yeah. It's a little strange, even physicists will tell you that.
I bet.
Think of a coin spinning in the air.
Okay.
It's not heads or tails until it lands.
Right.
Qubits are kind of like that, the state of superposition.
So both heads and tails at the same time until we look at it.
It's a good way to think about it.
Okay, so that's superposition.
Yeah, and that's what gives quantum computers so much potential.
More than just speed, right?
Way more. For certain problems, they're not just faster, they're exponentially faster.
That's incredible. But how does this tie into microchips? Are we making quantum computers with the same chips?
That's a great question. While some of the fabrication techniques are similar, quantum computers need specialized chips.
To handle those qubits.
Yeah, it's not just smaller transistors anymore, it's a whole new type of chip.
That can harness quantum mechanics.
Exactly. And there are all sorts of new challenges.
Like what?
Many quantum computers have to operate at super low temperatures, close to absolute zero.
That's colder than space.
It is. It's a massive engineering feat to create and maintain those conditions.
It sounds like we're on the edge of a computing revolution.
Oh, we are. And it'll impact everything. Drug discovery, material science, AI, cryptography, you name it.
It's wild to think we're just scratching the surface of this technology.
We are. And that's just one advancement.
Right. What else is going on?
3D chip stacking is another big one.
3D chip stacking. Okay, what's that?
Imagine taking those microchips we talked about
Hmm.
and stacking them up like a microscopic skyscraper.
So instead of flat chips, we're making 3D chips with layers of circuitry.
Exactly. More transistors in the same space, more power, more speed, less power consumption.
So it's like getting more bang for your buck, but on a tiny scale.
Exactly. And shorter connections, faster data transfer, less lag.
So just stacking them up makes things faster and more efficient.
Yeah, it's pretty amazing. And we're only going to see more improvements as the technology gets better.
It's incredible what we can do with these tiny components.
It is. The ingenuity is incredible.
Okay, so we've got quantum computing, changing how we process information, and 3D chip stacking, taking performance to a whole new level.
It's exciting, isn't it?
It is. What else is shaping the future?
New materials are a huge area of research.
New materials, so beyond silicon.
Exactly. Silicon has been the king for a long time, but researchers are exploring new things, better performance, better efficiency, even new functionalities.
Like what kinds of material?
Well, there's graphene, for one. It's a single layer of carbon atoms arranged like a honeycomb.
Wow.
Incredible conductivity and strength.
And that can be used in chips?
Potentially, yeah. There are also new types of semiconductors, even faster, even lower power consumption.
It sounds like a materials revolution.
It is, and it's not just finding them, it's learning how to work with them at the atomic level.
So we're not just changing what we build with, but how we build it.
Exactly. It's a really exciting time to be in this field.
It sounds like it. Quantum computers, 3D stacking, new materials, the possibilities seem endless.
They really do. And those are just a few of the innovations happening.
So we're on the verge of a new era of microchip technology,
We are.
one that's going to keep changing how we live and work.
Absolutely.
But with all this power comes responsibility.
Right. That's a great point, and that's something we'll discuss in the final part of our deep dive.
Stay tuned as we wrap up our journey through microchip manufacturing. Welcome back for the final part of our microchip deep dive.
You know, we've really gone on a journey here.
We have from sand to smartphones.
And beyond silicon.
Right, to
Yeah.
quantum computers and all those incredible advancements. It's clear microchip technology is going to keep shaping our world.
Oh, absolutely.
But we need to talk about the bigger picture.
Implications.
Right, because microchips aren't just about faster gadgets. They affect society, the economy, even the environment.
Exactly. So let's dive into those critical considerations.
Okay, let's start with the environment. We talked about how precise and complex chip manufacturing is, but that comes at a cost, doesn't it?
Yeah, it does. Making microchips uses a lot of resources. Energy for purifying silicon, water for cleaning and etching.
And I imagine some of the chemicals used aren't exactly eco-friendly.
Some can be harmful, yeah, if not handled properly. But the good news is the industry is really focusing on minimizing its environmental impact.
So what are they doing to make things more sustainable?
Well, there's a big push to reduce energy use, more efficient processes, switching to renewable energy sources.
Makes sense. What about the chemicals? Are there any alternatives being explored?
Oh, definitely. Researchers are looking at new materials and fabrication techniques that are much less harmful.
So it's not just about doing less harm. It's about actually doing good.
Exactly. Some companies are even trying to use recycled materials in chip production.
That's great. Sounds like sustainability is becoming a top priority.
It's definitely moving in that direction, and it has to, because the demand for chips is only going up.
That brings us to the economy. Microchip manufacturing is global, right? With these complex supply chains.
Very complex, spanning multiple continents.
And we've seen recently how fragile those chains can be. Pandemics, natural disasters, even geopolitical tensions.
Yeah, any disruption can cause shortages, price hikes, delays in production.
And that affects everything from our phones to critical infrastructure.
It does. So there's a big push to make supply chains more resilient, diversify production, maybe bring some manufacturing closer to home.
So finding that balance between globalization and regionalization.
Exactly. Governments are getting involved too, investing in domestic chip manufacturing, building partnerships to strengthen the industry.
It's a complex issue, for sure, but a stable chip supply is vital for the global economy.
Absolutely. Now, let's talk about the impact on society. Microchips are everywhere now, in our phones, computers, cars, even medical devices.
It's true. It's hard to imagine life without them.
And that raises some important questions about data privacy, security, even the potential for misuse.
Right, because with so much of our lives running on chips, who has access to our data? How is it being used?
Those are critical questions, and as chips get even more powerful, those concerns will only grow.
So how do we ensure this technology is used responsibly and ethically?
Well, it starts with having open conversations about these issues. Policymakers, industry leaders, the public, everyone needs to be involved.
Finding that balance between innovation and responsibility.
Exactly. We need guidelines, regulations, safeguards to make sure this technology benefits humanity.
And we need to think about the potential for job displacement as automation and AI become more prevalent in the industry.
Absolutely. Investing in education and training programs, helping workers adapt to the changing job market.
So everyone benefits from these advancements.
Precisely. So, as we wrap up our deep dive into microchips, let's appreciate just how far we've come.
From silicon to smartphones, from the science and engineering to the impact on our world, it's been quite a journey.
It has. And it's clear that microchip technology will continue to shape our future in profound ways.
So next time you use a device with a microchip, remember the incredible process behind it.
And think about the bigger picture, the challenges and opportunities.
Because the future of microchips is about more than just bits and bytes.
It's about shaping a world where technology empowers us, connects us, and helps us build a better future for everyone.
And that's a wrap on our deep dive into the world of microchip manufacturing. Thanks for joining us.